Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. My name is Asman. We are from Group 10 and we'll be presenting about the Hamming code programming. And for my part, I will be talking about the first part of the code. And this is the main function. And in the main function, we'll be declaring the variable array A10 and array B10, C1, C2, C3, and P. But for my part, we'll be only using the array A10. So first of all, we'll be prompting the user for 4 bits. And this 4 bits will be the data bits. And this data bits will be stored in A3, A5, A6, and A7. Now after we get all these 4 data bits, we'll be calculating the parity bits. To calculate the parity bits, we will use this formula here. And this A1, A2, A4 here is the parity bits. They can be also known as P1, P2, P3. Here is A1, A2, A4. So yeah, for A1, to calculate A1, we use A3 to the power of A5 to the power of A7. A2 is A3 to the power of A6 to the power of A7. And A4 is A5 to the power of A6 to the power of A7. And after we get all these bits, we can compile the data bits and the parity bits into a whole 7 bits. And after all this calculation, we'll be displaying these 7 bits. And to calculate, to display the 7 bits, we use this. We display it like this. And let's execute this code. Okay, enter 4 bits. 1, 0, 1, 1. And the 7 bits are 0, 1, 1, 0, 0, 1, 1. And there you go. And to the next presenter.
Assalamu alaikum. My name is Nasr Khalil Ahmed Hassan. Here I'm going to explain what my friend started already, which we will begin with entering the 7 values. So for the receiver side, we will again input whole 7-bit code. Yes, from here. Which consisted of a party bit and data bits. So here we can see this message saying to input the 7-bit to input the 7-bit. If the 7-bit are same as that of the array variable, then that means there is no error in the code. But if there any changes, we'll find it by using Hamming code. So here, yeah, you can see here. Yeah. So here we input a new 7 into a new variable b. Now again we will find a party bit, but now for finding the activity we'll consider this first elements as well, because we now know the value of the party bits as it is 7-bit at it's 7-bit 7-bit code. So here we calculate, yes, here. So here we calculate the value of a party bit. So after calculating the party value, now we'll convert the party bit value the party bit value into and the decimal format. If the value is 0, then that means there is no error in the code. But if the other than 0, there is any value, that means there is no error in that particular position. That's all. Thank you so much.
Assalamu alaikum, my name is Ismail and I will continue with step 3 for our Hamming code program. So once we have our data bits and parity bits, we can find the position of an error if there is one. To do this, we have to convert the parity bits from binary to decimal. These are the lines of codes for our program for this step. In the first 3 lines, we use an XOR operator to get the binary parity bits. The example to the right basically shows us how it's done. So let's say for our C1 we get 1, 0, 1, 0 from position 1, 3, 5 and 7. This will equal to 0 as it is an even parity, as it has an even number of ones. If we apply the same thing to C2 and C3 with their respective bit positions, we will get 1. Now we can change this from binary to decimal, which can be seen in the 4th line of code, which is basically P equals to C1 times 2 to the power of 0 plus C2 times 2 to the power of 1 plus C3 times 2 to the power of 2, where P is the position of error. By using the values from our previous example into our C1, C2 and C3, we will get 0 plus 2 plus 4, which equals to 6, meaning that there is an error in the 6th bit position. Also, if our P is ever equal to 0, then that means that there is no error. That will be all from me. I will now pass it on to the next presenter, who will show us how this will be displayed in the console. Thank you.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Muhammad Amr and I will explain my part about detect error. So in this example we have 7 bits 1 1 1 0 1 0 1. So how do we check if the parity bit has an error or not? By checking if it's even or odd. So in this example we have parity 1 which is equal to 1. So we add d3, d5 and d7, which is 1 plus 1 plus 1, which is 3, and 3 is odd, so that's correct. Parity 1 bit is correct. In parity 2 we have 0, so in parity 2 to check if it's correct or not, we have to add this 3, d3, d6, d7, which is odd because it is 3, 1 plus 1 plus 1 is 3, so it should be 1, not 0. Same goes for P4. In P4 you have to add D5, D6 and D7, which are also odd, which should be 1. So that's how we detect an error. In P2, P4 we have 2 errors. Thank you.